Hi friends, welcome to my another video. Today in this video, I will discuss about the selection of CT. During the selection of CT, the four criteria we have to consider, that is the CT ratio, CT burden, accuracy class and the dimension of the current transformer. So let's study how to select the current transformer. For that, I have taken one example. This is a SMDB and we need to select one CT for this SMDB. The total connected load for this SMDB is 250 kilowatt, which I mentioned here. Total connected load is 250 kilowatt. As I told you, in order to select the correct CT, the first criteria is to calculate the CT ratio. So here in our example, the total connected load is 250 kilowatt. So the total current will be 1.74 into 250 kilowatt. So the total current will be 435 ampere. How I wrote this value 1.74 is, what is the formula for P? For in three phase, P is equal to root 3 into V into I into cos phi, right? So what would be the value of I? I will be P by root 3 into V into cos phi. If we will substitute all the value, like we can express this relation like 1 by root 3 into V into cos phi into P. If we will substitute the value of root 3, that is 1.73, V 415 and cos phi as 0.8, then we will get the value 1.74. So I use here the shortcut method. You can also use this shortcut method for three-phase system in order to calculate the load current. So here the total load current came as 435 ampere. In order to calculate the rated primary current of current transformer, we have to take 20% as a safety margin. So we have to multiply the total load current with the 1.20 in order to have 20% safety margin. So after multiplying, we will get the value of 522 ampere. So the next standard available CT size is 600 by 5 or 600 by 1. We can choose any of them, 600 by 5 or 600 by 1. There is a criteria to choose secondary current of the CT as 5 ampere or 1 ampere. Let me give you one example to make you understand when we should choose 5 ampere as a secondary current of the current transformer and when we have to choose 1 ampere secondary current of a current transformer. Suppose there is a transformer which is situated outdoor and there is a control panel for this transformer situated indoor, and the distance between the transformer and control panel is 200 meter. Okay, there is a CT nearby the transformer and there is a metering device or the protective relays in the control panel. So from CT to the metering or protective device there is wires, control wires, which have a distance of 200 meter, as the panel and the transformer is far from each other by 200 meter. In order to connect this CT with the protective devices or the metering devices, we need to connect with the control wire, and the distance of the control wire is 200 meter. I hope you got till here. Okay, if the distance between the CT and the protective device like relays or the metering device like ammeter, power factor meter or multifunction meter is far from each other, then it is better to choose 1 ampere as a secondary current. And if the CT and the metering or protective devices are connected adjacent to each other, then we can choose the secondary current as 5 ampere. Why I'm telling this one? Suppose this control wire offering a resistance of 1 ohm, then what would be the power losses in the control wire? That is I square R loss. What is the I here? Secondary current, that is 5 ampere. And so what would be the I square R losses is 5 square into 1 ampere, that is 25, right? Suppose another case, that is the CT has the ratio of 600 by 1 in this case. So what would be the I square R losses? That is 1 square into 1, that is 1. this I square R losses is nothing but the burden on the CT. So when the CT ratio was 600 by 5, then the burden was 25 times more than when the CT ratio is 600 by 1. So the conclusion of whole discussion is that when the CT and the protective and metering devices are far from each other, then we have to go for the secondary current as 1 ampere, because the burden on the CT will be less. And if the CT and the metering or protective relays are adjacent to each other, then we can go for the secondary current of CT as 5 ampere. In my case, the CT and ammeter is adjacent to each other because it is installed in a same panel. Then I will go for a CT of CT ratio 600 by 5. I hope you clearly understand how to calculate and how to select the CT ratio. So we completed the CT ratio calculation in order to select the correct CT. Now let us go for the second point, that is the CT burden. We need to calculate the CT burden. As I told you, in my case, I have to connect one analog ammeter with this CT. So as the CT ratio we selected as 600 by 5, and I need to connect an analog meter with the CT in order to measure the current. Okay. As per this chart, we can see that the analog meter has the burden of 1 VA. Okay. Then my CT burden which I'm going to select must be greater than 1 VA. So I can go for either 1.5 VA, 3 VA, 5 VA, 10 VA, any CT I can select because my burden on the CT is only 1 VA. Now suppose my plan is to connect with my CT of 600 by 5 CT ratio, 1 ammeter, 1 kWh meter and 1 power factor meter. This is my plan to connect with this CT. So what burden CT I should select? As per this chart, for the analog meter, the VA value is 1 VA. Okay. For the kWh meter, the VA value is 2 VA. So 2 VA. For the power factor meter, the VA value is 2.5 VA. So we have to sum it. That is 1 plus 2 plus 2.5. It will come 5.5 VA. So we have to choose a CT which have a CT button more than 5.5 VA. In that case, we will go for 10 VA CT or 15 VA CT or 20 VA CT or any other VA CT. Here I want to highlight one more point. If you are selecting a CT which is of metering type, then you can go for any burden CT higher than your calculated burden. Means if your burden is 5.5, then need not to select the next higher size CT burden. You can go for any other burden like 15 VA, 20 VA, 30 VA, 45 VA and 60 VA. This will give you a very big benefit. This I will discuss in my next video, because if I will discuss this thing in this video, then my video will be very big. In order to better understand CT burden, let us take another example with small changes. Here in this time, I have to connect with this CT which have a CT ratio of 600 by 5 with an ammeter, but this time the ammeter is very far from the CT, that is 200 meter far from the CT. Okay, and this wire resistance is 5 ohm per kilometer. So the total resistance offered by this 200 meter wire will be 5 into 200 divided by 1000, which is 1 ohm. This is a simple mathematics. So the total resistance offered by this 200 meter wire is 1 ohm. Okay, so what would be the IR square losses? That is the secondary current which is flowing through this lead wire which is connecting the ammeter into the resistance of this wire. So what would be the I square R losses? Secondary current square into resistance offered by the wire. So it is 25 VA. Now the ammeter has some VA, that is 1 VA. In this case, the VA value of the CT should be 25 VA which is offered by this control wire and plus 1 VA which is offered by an ammeter. So 26 VA. In this case, we have to select a CT which have a VA rating more than 26 VA, that is we can go for 30 VA, 45 VA and 60 VA. So why I took this example, you need not to check only the ammeter or the metering device which is connected with the CT in order to calculate the CT button. We have to check that the ammeter or the metering devices which is connected with the CT is how much far from each other. If it is in the same panel adjacent to each other, then this calculation we need not to make, because the wire length will be 1 meter or 2 meter, which is very less, so we can neglect this one. But if the CT and the measuring devices is very far from each other, then we have to calculate the VA offered by the control wire. Hope you understand this one. In my previous first case, there is an ammeter of analog meter and the same CT ratio, but the VA value is only 1 VA. With the same CT ratio and same ammeter, if the distance increases, then the burden of the CT rating also increases. In first case, we can select the VA of 1.5 VA, CT burden as 1.5 VA, but as the distance increases, then we have to go for the CT burden of 30 VA or 45 VA and 60 VA. Hope you understood how to calculate the CT burden, or how to select the CT burden for a particular CT as per your requirement. So in order to select the correct CT, we completed the second criteria also. We learn about how to select the CT burden or how to calculate the CT burden. Now let us move further to calculate the accuracy class of a current transformer in order to select the correct CT. First we will go for the accuracy class for the protection current transformer. Then we will check the accuracy class calculation for the metering type current transformer. But the CT button for metering type current transformer and for the protection type current transformer is same. The only difference in the metering type current transformer CT button and the protection type current transformer CT button is that, suppose if we calculated the CT button as 5.5 VA, then for the metering class we can go for any other higher value of CT button like 10 VA, 15 VA, 20 VA, 30 VA, 45 VA and 60 VA, and this will give one big benefit which I will explain in my upcoming video. But for the protection type current transformer, if we calculated the CT button as 5.5 VA, then we should not go for the more higher rating of the CT button compared to our calculated CT button. Now let us calculate the accuracy class for the protection type current transformer. As in my previous video, I explained you how to decode the accuracy class numbers, like here 5P10. The 10 here indicate the accuracy limit factor, which express that, suppose if the primary current is 100 ampere rated primary current for the CT is 100 ampere, then the core of the CT will not get saturated until there is a 10 time of the rated primary current flows through the primary conductor. Means till 10 time of the rated primary current of the CT, the core of the CT will not get saturated and it will give the reading with 5% error. If you want to know deeply about the accuracy class of metering type current transformer and accuracy class for the protection type current transformer, please watch my video, link in the description below. Now let us calculate the accuracy class for the protection current transformer. Here in our example, you can see that the maximum system fault current is given as 10 kilo ampere. This value is important for calculating the protection type CT transformer accuracy class. So here I wrote system short circuit fault current is 10 kilo ampere and we selected the CT is 600 by 5. The accuracy limit factor, this one, the accuracy limit factor is system short circuit fault current divided by rated primary current. What is system short circuit fault current? What is the maximum possible short circuit current can occur in the system? That is called system short circuit fault current divided by rated primary current. For here our selected CT, the rated primary current is 600 and the system short circuit fault current is given as 10 kilo ampere. So we'll divide this one, then it will be 10,000 divided by 600, then the value came as 16.6. This 16.6 express that the core of the protection type current transformer will get saturated when there is a primary current 16 16.6 times than the rated primary current of the CT. What does it mean? It means that when there is a 16.6 time of the primary current, which is 600 ampere, is flowing through the primary winding of the CT, the core of the CT will not saturate, and it will saturate after 16.6 time of the primary rated current. Suppose the core of the protection type current transformer gets saturated when there is a 10 time more than the rated current during fault condition. Then what will happen? CT core will saturate. Then the secondary current will not change as the core of the CT is get saturated. Even there is a high current flowing through the primary conductor. Then it will not give signal to the relay, and relay will not give command to the tripping circuit to break the circuit. So from this discussion, we can say that the accuracy limit factor for the protection type current transformer should be high. If the accuracy limit factor will be very high, many multiple times of the rated current, then the CT core will not get saturated during the high fault current, and it will give the correct signal to the relay, and relay will trip the circuit. Let back to our example. Here the accuracy limit factor is 16.6. It means when there is a 16.6 time of primary current is flowing through the conductor, the CT core, protection type CT core, will not get saturated. So 16.6 accuracy limit factor is not coming. The standard accuracy limit factor coming beyond 16.6 is 20. So we will select the CT which have the accuracy limit factor as 20, and if we want only 5% error when there is a 20 time primary current in the rated primary current in the primary conductor, then we have to go for the 5P. If the accuracy is not that important for us, then we can also go for 10P. It means when there is a 20 time of the rated primary current is flowing through the primary winding, then the CT will give reading with 10% error. So either we can go for 5P20 or 10P20. Hope you clearly understand how to calculate the accuracy class for the protection type current transformer. Now let us calculate the accuracy class for the metering type current transformer. The accuracy class calculation for the metering type current transformer is very easy. As we take in the CT which have the CT ratio as 600 by 5, then if we want a very accurate result, then we will go for 0.1 class. What does it mean? It means that when there is a 600 current is flowing through the primary winding or the primary conductor of the CT, then this CT will give an error of 0.1% of this 600 ampere, that is 0.1% of the rated primary current. Suppose I have selected a class 1. Then what this class 1 indicate? Class 1 indicate that when there is a 600 ampere of current is flowing through the primary winding of the CT, then the CT will give 1% error of its rated primary current. What does it mean? The 1% of 600 is 1 divided by 100 into 600. So it will be 6 ampere, right? So this CT will give an error of 600 minus 6 to 600 plus 6, that is 594 to 606. So it means that when there is a 600 ampere of current is flowing through the CT primary winding, then the CT give reading of 594 or 606 or any reading between this range. Hope you clearly understand what is the accuracy class for the metering current transformer and how to calculate and how to select, better to say select the accuracy class for the metering type current transformer. If you need very precise accuracy, then go for the lower value. After calculating the CT ratio, CT burden and accuracy class, we can specify it here. Suppose as this CT is a metering type CT, so the CT ratio is 600 by 5, the accuracy class is 1, and the burden of the CT is 15 VA. Suppose if I have one CT which is of protection type CT, then the CT ratio is 600 by 5. The accuracy class is 5P20 and the CT burden is how much CT burden? We calculated 5.5. So we will go for the first nearest higher value, that is 10 VA. So we can say that 10 VA. I hope you clearly understand how to select a correct CT by calculating the CT ratio, CT burden and the accuracy class. In my upcoming video, I will try to explain the dimension of the CT and its significance while placing the order for the current transformer. I hope you find this video very informative and you learn something new from this video. If you really like my video, then please give thumbs up and subscribe to my channel. We will meet in any other video. Till then, take care, keep learning and bye-bye. Thank you so much.